Hi, this is Mrs. Doris. This is Algebra Lesson 8.3 entitled Multiplying Binomials. Our objective is you are going to multiply two binomials together, and we also have an example where you will multiply a binomial by a trinomial. All right, so we're going to go right into the problems. We're going to show you several different ways that you can use to multiply polynomials together, and you may use any method that you wish. I will not dictate to you that you have to use the distributive property, or you have to use a table, or you have to use the FOIL method, but you can use whichever method you prefer. All right, so problem one. This time we're going to use the distributive property. So what is a simpler form of the quantity x minus 6 times the quantity 4x plus 3? All right, well, in distributing, what we're going to start with is our very first term, and we're going to distribute it to each term in the second polynomial. In other words, we're going to take the x and multiply it first times the 4x, and then we're going to take the x and multiply it times the 3. All right? Then we're going to take the negative 6 term and distribute it to each term in the second binomial. All right? And this is what you call using the distributive property. So multiplying all of this together, x times 4x would be 4x squared. X times 3 would be plus 3x. Minus 6 times 4x is minus 24x. And minus 6 times 3 is minus 18. Now, the only thing that we can combine that are like terms are the two terms in the middle, the 3x and the minus 24x. So our answer would be 4x squared. Plus 3 minus 24 would be minus 21x, and then minus 18. And this would be our answer. Problem 2, I'm going to show you how we do this using a table. So our question is, what is a simpler form of the quantity 3x plus 1? And so you'll see I've put 3x and plus 1 on one side of the table, and x plus 4 on at the top. Now, they call this a table. I sometimes call this an area model because it's like taking length times width. It's also somewhat similar to lattice. All right, so in our first blank we have the 3x times the x, which would give us 3x squared. Then I'm going to take the 3x times the 4, which would give us 12x. All right, next 1 times x gives us x, and 1 times the 4 gives us 4. And then again you want to add up your like terms. Now, if your binomials are in standard form, meaning decreasing order of exponents, and you're not missing an exponent, then you can, it's very similar to lattice in that your like terms are going to fall diagonally from each other. So we have 3x squared. Combining the x and the 12x, we get 13x, and then plus 4. All right, the FOIL method is one that you will want to learn this method, and I think that you'll enjoy it. If you like acronyms, this is the one for you. This is called the FOIL method. And we've used this in using the distributive property and in using the table, but this just kind of gives a nice acronym for it. F stands for first. You want to multiply the first terms together. O stands for outer. You want to multiply the outer terms together. I stands for inner. multiplying the inner terms together, and L stands for last. Multiply the last terms together. All right, so we're going to use the FOIL method, and this is not in your notes. So just please watch and listen, and if you have a question, please jot it down and make sure that you bring it to class. Now, the FOIL method, this one only works for binomials. There has to be two terms in each polynomial for this to work. So, multiplying first terms together. Our first terms are the 3x in the first binomial and x in the second binomial. So we're going to take 3x times x, which gives us 3x squared. All right. Our O stands for outer. Our outer terms are the ones that are on the outside. So we have 3x and 4. And 3x times 4 is 12x. All right. I stands for inner, and our two inner terms are the 1 and the x. When the binomials are placed side by side, they're going to be the ones in the middle. So 1 times x is 1x. And finally, our last terms are the 1 and the 4 in each binomial. So multiplying our last terms together, 1 times 4 is 4. And then again, we can combine like terms in the middle so that our final answer would be 3x squared. 12x plus x is 13x, and then plus 4. All right, and let me just show the 12x and the 1x combined to give you 13x right there. So there's your answer. Now, when I was in school, they didn't call it FOIL. My teacher called it the smiling sun or the smiling face. And it works the same way as FOIL, so this one is not in your notes either. So again, just pay attention. And you might like using this drawing, like we sometimes use in using the distributive property, to help you with multiplying two binomials together. And again, this only works for binomials. All right, so we're going to multiply the two first terms together. 5x times 8x is 40x squared. We're going to multiply the two outer terms together. 5x plus 2, or 5x times a positive 2 is 10x. We're going to multiply the inner terms together. Negative 7 times 8x is negative 56x. And then we're going to multiply the last terms together. Negative 7 times 2 is negative 14. And then we are still combining like terms. I'll bring down the 40x squared. Plus 10x minus 56x would be minus 46x, and then minus 14. Now, here's where the smiling sun comes into play. Let me get rid of the arrow here. You have one eye, here's an eye, here's your nose, and here's the mouth. All right, so that's the smiling sun. All right, so problem 3, using FOIL, what is a simpler form of each product? And so we're going to talk through it using FOIL, and I'm also going to use the drawing as well. First of all, first terms, 3x and x multiplied together give 3x squared. Outer terms, 3x times 2 would be plus 6x. Inner terms, negative 4 times x is minus 4x. And last terms in the binomial, negative 4 times 2 is negative 8. All right, let's combine like terms. That would be combining our plus 6x and minus 4x, which gives us a positive 2x. Bring down the minus 8, and here is our answer. 3x squared plus 2x minus 8. working the next one. First terms, we're going to take n times 4n would be 4n squared. Multiplying the last terms, n times minus 7 would be minus 7n. Multiplying the inner terms, minus 6 times 4n would be minus 24n. And multiplying last terms, negative 6 times negative 7 is a positive 42. All right, combining our two like terms, which are in the middle, negative 7n plus a negative 24n would be a negative 31n. And here's our answer. All right, and our last problem, first terms, we're going to take 2p squared times 2p, which would be 4p cubed. And I'm going to move this down just a little bit to make, I'm not leaving very much room for my mouth here. Outer terms, 2p squared times minus 5 would be minus 10p squared. My inner terms, positive 3 times 2p would be a plus 6p. And multiplying last terms together, 3 times negative 5 would be negative 15. And you'll notice that in this case, we don't have any like terms. So this would be our answer. 4p cubed minus 10p squared plus 6p minus 15. All right, now you'll notice we are skipping problem 4 in the book. You won't have to deal with that. Problem 5. Here we're multiplying a trinomial and a binomial together. Now, the FOIL method won't work for this one. The table method will work, and then there is also another method, which I simply call a traditional method. I always put my bigger polynomial on top. So I'm going to write this one first, 2x squared minus 3x plus 1. And then I'm going to take my smaller polynomial, x minus 3, and write it underneath. Now, this method is just like multiplying two numbers together traditionally. First of all, you start with the negative 3. Negative 3 times the 1 gives you negative 3. It's like multiplying the 1's digit times the 1's digit. Now let's go to the tens. We're going to take negative 3 times negative 3x, which would be a positive 9x. And a negative 3 times the 2x squared, which would give us negative 6x squared. Okay? Then we go to, like in regular multiplication where you go to the tens digit, we're going to go to the x. And we're going to multiply the x times the 1, which would be 1x. X times the negative 3x, which would be negative 3x squared. And then the x times the 2x squared, which would be 2x cubed. Draw your line, and now you're going to add like terms together. So 2x cubed has nothing to combine with it. The negative 6x squared minus 3x squared would be minus 9x squared. Plus 9x plus 1x would be plus 10x. And then minus 3. All right, and you can always show the plus 0 here like you do in traditional multiplication, or you can just leave a space too. It's not necessary that you show it. Let me also show you how this works for a table method. What you want to do is draw a 3 by 2 table. I'll put my 2x squared minus 3x plus 1, and then my x minus 3 over here. And then again, we're going to multiply length times width, or however you want to talk about it. X times 2x squared would be 2x cubed. x times minus 3x is minus 3x squared. X times 1 is 1x. Moving to the row 2, negative 3 times the 2x squared is negative 6x squared. Negative 3 times negative 3x is 9x. And negative 3 times 1 is negative 3. All right. Now, once again, your like terms, if you'll notice here, 2x cubed, there's nothing like it, so we'll just bring it down, 2x cubed. The x squared terms are diagonal from each other. Negative 6x squared and negative 3x squared combine to give minus 9x squared. All right, then you've got your 9x and your x. We can put those together, which would give us plus 10x. And then finally, you've got minus 3. Now, you may notice this looks just like lattice, and it is. When this will not work to add diagonally is if we were, say, missing one of our terms, like a minus 3x here, then your terms may not line up appropriately. For instance, if I go back to this problem C here, I have a 2p squared and a plus 3, but I don't have a p term in here, and that's gone. And so if I were to use a table method for this one, you'll notice nothing combined in our answer to begin with. So be very careful if you use a table method to make sure that you are combining like terms. All right, if you have any questions, please see me in class or shoot me an email, and I will be happy to answer it for you. Thank you very much.